In this example, we will be evaluating the square root of 11. The square root of 11 doesn't give us an answer that is a whole number or a terminating decimal. So what we want to do is look at perfect squares nearby to 11. For instance, 3 squared is equal to 9, and 4 squared is equal to 16. So we can see that 11 fits between 9 and 16. From this information, we can write the following inequality. 9 is less than 11, which is less than 16. Now we can take the square root of all of our values in the inequality. The square root of 9 is less than the square root of 11, which is less than the square root of 16. Now the square root of 9 is equal to 3, as 3 squared is equal to 9. The square root of 16 is equal to 4, as 4 squared is equal to 16. Now we can see that 3 is less than the square root of 11, which is less than 4. To find a tenths place approximation, we want to look at values between 3 and 4 that multiply by themselves to get 11. Because 11 is closer to 9 than it is to 16, we'll try values closer to 3. For instance, let's try 3.3 times 3.3. This is 3.3 squared, and we're trying to see how close we can get to 11. 3 times 3 is 9, 3 times 3 is 9, add our 0. 3 times 3 is 9, and then 3 times 3 is 9. When we add these together, we end up getting 10.86, which is very close to 11. So we can say that 3.3 squared is approximately 11. Or we can take the square root of both sides and say that 3.3, which we get from canceling out the squared and the square root, is approximately the square root of 11.